Hello and welcome. My name is Matthias Bär, and today I would like to show you a short video about spectrum analysis using an oscilloscope. The oscilloscope we use today is our high-performance oscilloscope called RTP, and as signal source I use a vector signal generator, SMBV. On the signal generator I have set up a very fast frequency sweep starting at 1.5 GHz, going in 50 MHz steps up to 3.5 GHz. I have already connected the signal generator with the oscilloscope, and we see on the oscilloscope the signal already which is coming from the signal generator. We see here the amplitude of the signal, and we see that something is changing, and in order to have a closer look into the signal we use the zoom functionality of the oscilloscope, and we simply draw an area around the signal to go into this signal to zoom into that time domain signal. We can apply tools like the gestures to zoom in or to zoom out. We can move around the cursor window. So everything what you probably know already from other instruments from Rohde and Schwarz, or maybe from your smartphone. But the topic today is spectrum analysis, and we have the time domain signal, and now I would like to show you how to perform the spectrum analysis. For that we have our toolbar here, and we have a dedicated icon. It's called FFT. When I press the icon on the sidebar, a window pops up where I can define the typical spectrum analyzer parameters. Typical spectrum analyzer parameters are start frequency and stop frequency, or center frequency and span, but also the resolution bandwidth which I would like to use to perform the spectrum analysis. And this is what we are doing now. So first I define a start frequency, and I would like to start at 1 GHz, and I would like to use a stop frequency of, let's say, 4 GHz and the resolution bandwidth of 2 MHz, which is okay. Now, in order to enable the FFT, I simply press the source I want to use for the FFT. In this case, it's channel 1 signal, and I get an immediate response of the FFT, and you see the really fast update rate. The really fast update rate allows us to follow this fast frequency sweep, and in order to display the frequency variation and maybe also the power variation versus time, we have an additional display mode in our FFT functionality implemented. It's called the spectrogram, and I would like to show you how to enable the spectrogram. In order to do this, we go again into the menu where we defined the FFT, and you see here the parameters we have defined. The resolution bandwidth, start stop frequency, and then there is a third column, it's called spectrogram, and I simply enable this one and I get an additional display. It's the spectrogram, it's a frequency and power versus time display, and in order to have more space on the display, I minimize the time domain signal. The time domain signal goes to the sidebar. It's still active. You still get a lively update of that. And now we have here the frequency domain signal, and we have the spectrogram signal, and I can also change the color using our intensity knob and make it even more visible. So here we see the frequency, the spectrum of my time domain signal. In the upper part I see the variation of frequency and power versus time. So this was the short video about doing spectrum analysis with an oscilloscope. I hope you liked the video, and I'm looking forward to see you the next time. Thank you and goodbye.